Hey everybody, welcome. This is Naveed Kehani. I'm one of your TAs this semester. I'm recording this video as a bonus material for Professor Sebastian Goodfellow's CIV 1498 at the University of Toronto. In this video, I'm going to be talking about a few essential tools you should learn as a data scientist. These tools hopefully can help you get your course assignment projects done more easily and more efficiently, and hone your skill sets for your future careers. So without further ado, let's get started. Okay, on this slide, I have listed the tools that we thought would be helpful for you during this course. So these tools are those that software engineers and data scientists might use even on a daily basis. And we as civil and mineral engineers might not be exposed to them as much. So we thought we introduce these tools to you and give you an overview about these tools, and you could just look up online. There are lots of great resources for learning these tools more in depth, but this is just a brief, really gentle introduction to these tools that you might find helpful for CIV 1498. So we'll start with Anaconda. I assume that you have seen how to install and use Anaconda, but we're going to install Anaconda from scratch and see how to use it really briefly and quickly. Then we're going to move to IDEs and PyCharm in particular. IDEs basically are text editors for developers. There are environments in which you could code, debug, and basically do the programming part. Then we're going to talk about Git and GitHub, how we could collaboratively work on a single project, how we could control the versions, how we could put that project that we are working on cloud and on the internet, and why they are important and useful. Then I'm going to really briefly introduce you the basics of command line interface, how we could command the machine using some text instead of the general GUI or graphical user interface. So, and why this might be helpful for you for this course. So let's start with Anaconda. Okay, as you might know, Anaconda is one of the main tools in any data scientist toolbox. So as you might know, Anaconda facilitates the package and environment management, which means that it comes with many scientific packages or libraries. And also it comes with many tools for development, like Jupyter Notebook, PyCharm, Spider, etc. So we're going to use Anaconda, and we're going to see how to install Anaconda. Okay, so the first thing to look up is Google, for sure. And what we do is to just search Anaconda download. We'll go to the first result. So on this page, you can see that the website has identified my operating system, or OS, which is Windows, and it suggests me downloading the Windows version. Also, as you might guess, we have different products from Anaconda. So we're going to use individual edition, which is open source and free. So if you go down, if the website somehow hasn't identified your OS correctly, you could just come down here and just select the proper one. But because it's selected the operating system correctly for me, I'm just going to download its recommendation. So this is the latest version with Python 3.9. So I'm going to just download this, and I'll come back. Okay, as the installer is being downloaded, I would like to show you the tools and packages that come with Anaconda. So if you click on this page, you can see the list of them. So there are a few things that we use really frequently, like Jupyter, Pandas, NumPy, and SciPy. You could just look them up, but Jupyter Notebook is or Jupyter is a web-based environment for working with notebooks. We're going to see them a lot. Pandas is for handling tabular data structure, basically tables and rows, column series. So these are the data structures that we work a lot with. And a lot of the other things like SciPy and NumPy, a lot of machine learning tools, data visualization tools, dashboarding. So these tools are, getting updated really frequently. So you could just look them up and see if there is any new thing that you could use in your project. So I just wanted to show you this, and we're going to get back to our slides. Okay, before that, let's install Anaconda on our system. So I have downloaded Anaconda and I just opened the installer. Basically just need to press next, I agree, etc. If you want to change the destination folder, you can do it here. And basically that's all you need to do. We wait until this gets installed and we'll get back. Okay, now the installer has done its job, and we're going to just continue pressing next until we get to this. And if you want to see the tutorial, you could check this box. Otherwise, we could just press finish so that we could get started with Anaconda. Okay, so now that we have Anaconda installed, we could just go on the search bar on Windows, for example, and search for Anaconda. And we're going to select Anaconda Navigator for now. So the Navigator comes with different tabs, and it's a graphical user interface for easy access to different tools. So when it opens up, you can see that we have different tools here. We're going to basically use Jupyter Notebook if we're doing things local on our local machine, basically. And also PyCharm is another tool that we're going to focus on. So there are different tools, you could just look them up, but these two are the main ones. Okay, if you go to learning, you could see that there are lots of resources for learning different tools, from Python to libraries, Jupyter Notebook, PyCharm, etc., and different seminars that you could just watch. I would like to also show you this, which is your environment. So we have already we already have one environment, which is called base or root, which has been built by Anaconda by default. So you can see that there are lots of packages installed under this environment. So if you, for example, would like to create a new one, and for example, you want to use Python 2.7 for any reason or any other versions, you could do that. So by default, it comes with 3.9 in the latest version. You could just name it and install whatever package that you want under this environment. And then you can have different environment with different packages installed, with different Python versions installed, etc. I just wanted to show you this as well. So the next part is working with PyCharm. But before that, let's see how IDEs work and what they are. IDE stands for Integrated Development Environment. We as data scientists need to read the data, explore the data, clean the data, visualize it, or maybe build models from data for our purposes. And all of these are possible using programming. And IDEs are where we actually write our codes. They are text editors that provide you with many other things, including debugging tools, auto-completion tools, build tools, etc. So they are useful for efficient and fast coding. For example, this is a screenshot from PyCharm's website. So you can see the environment here. But as you can see, you have different things going on here. So don't panic. We're going to get to all of them in the course, but you have debugging tools here. You could just put breakpoints in your code so that it stops when it comes to these breakpoints, and you can check different variables and do different things. And debugging actually an art, I would say. So you have different things. You have color-coded text. For example, all the functions start with def, and they are all in orange. You could configure them, but this is the default, etc. You could just search for different things. You could rename a variable in your entire project, your entire document. So this is where we actually write our code. So IDEs are where we actually write our code. That's all. Okay, let's get back to our Anaconda navigator. So as I said, we would like to use PyCharm. And for that, we're going to install this. So you have some tools already installed on your machine, and you just need to install whatever that is not here. So for example, PyCharm is not installed on my machine. I'm going to install that. So when you click on the install button, you're going to get directed to this page. And again, based on your OS, you're going to get a file for download. So for Windows, we are going to have executable files. And if I press download now, it's going to direct me here and start downloading the installer. Okay, once the download is finished, you can just open up the installer for PyCharm. Again, it's really straightforward on Windows. So maybe you could find this a little bit useful. So if you want to create a desktop shortcut, you could just check this. If you want to associate all the .py files with PyCharm, you can check this, etc. So I'm going to just check the association checkbox. And yeah, here we go. So it's going to install PyCharm on my machine, and I'll get back to you once it's finished. Okay, once the installer is done, you could just open up PyCharm. So as you might know, PyCharm comes with different editions, and this one is the professional edition. We have a community version, which is free and open source. You could use that as well. But you could use this one too, because you are a student here, and students have a 1-year license free. So you could use that. So for that, you need to create a student PyCharm account. So for that, we're just going to Google here. So we're going to say, for example, PyCharm student. And you can see that free educational licenses are available here. So you need to just apply for that, and it takes you a few minutes. You enter your details here, apply for free products, and you're going to get a free account that can be used for this professional edition. Okay, once you have applied and the application is complete, you come back to this window and click login to JetBrains accounts. You enter your username and password, press sign in, and then you're authorized to use this IDE for free. And you can see that I have an educational license and it's active until the end of the year. So now that we have our PyCharm set up, let's look at the welcome page of the application. So you have three options in your welcome page. So you can start a new project. You can open an already owned project, or you can get it from a VCS, which stands for Version Control System. This is our next topic, Git and GitHub. So stay tuned. But before that, let's look at the first two options that we have. So open is straightforward. Let's start a new project. So if you click on this, you're going to see that we have a few options here that we're going to mainly work with pure Python. You could just specify the locations that you want to save your project. You could change it if you want. But the only thing that I wanted to really show you is this part, the new environment using what. So it's virtual environment is selected, but if you have Anaconda installed on your system, if you click on this little triangle, you could see that Conda is one of your options for environment. So this, if you just leave it like this, you can see there is an error here. It says that I cannot find Python. But when you install Anaconda, you have the latest version of Python installed. So you could choose from 3.9, 3.10 even, and other things. So let's stick with 3.9. And you could just create a new project. Okay. So this is what it looks like. So it tries to build up your project. You could see some tips if you want. And here we go. You have your first Python project. So you could see this breakpoint here. So you could just press run. And it's going to run your program. That's easy, right? So when you hit run, whatever that is after this if statement is going to be executed. For example, if I say print civ 1498 and press run again, you can see that it's being executed. So that's cute. So if we just put breakpoint here and we go to debug mode, the program will stop at line 9 where we put our breakpoint. So another interesting thing that I would like to draw your attention to is this window here, when you can watch variables. For example, here we have a single variable which is called name, and the value for that is PyCharm, the value that we set to it, right? So basically what it does, it starts from this if statement, it goes into it. It goes into this function, which is print high, and stops at line 9. So you could just step over this and go to the following line. You could step into a function, or you could step out of a function. So if I step over, it gets back to the main path, and it then it goes to print civ 1498, and if I press this again, it's going to finish the execution. Okay, now let's talk about Git and GitHub. Let's start with Git. So what is Git? Git is a version control software application, and we use Git for tracking changes in our files, especially text files, like code that we are working on, a thesis that we're writing, a report, an assignment, a book. So we could track changes in our files. And it allows us to collaboratively work on the same project. So let me give you a few examples. So what we usually do when we are writing a report is that we start with a file, we name it just like D1, we start working on it, and maybe we copy that after a while because we don't want to mess with that and save everything on it. So we name it D2 and we continue maybe until we get to a final version. So after we are done, or at least we think we're done, we notice that, okay, this is not really final. I need to make some changes. So let me save this and just leave it as it is and copy that or save or click on save as and copy that another way. So we can have another file that is named final new. I work on it and make my changes, and this story continues because my supervisor says that, okay, it's not good. You need to, make some changes on it and so on. So it's going to be forever, right? So we may have final infinity, right? So this is somehow a framework for tracking changes in our file. But the problem with this is that actually we need to sort all of these things. And if we want something from the past, for example, before my supervisor just comment on this, I remember that I had something good, a figure that I just accidentally removed, right? But I'm not sure which version is the most updated one, right? So I need to just go back and grab that figure, and it's really frustrating. So Git makes this really easy for us. We know what changes have been made at each checkpoint, for example, D2, and we could just get back to it easily without losing anything. And we could just check it out. So this is one example of how Git could be useful. Okay, now let me give you an example about collaborative developments. I think it's clear, but let's do it. So let's say we have two developers who are working collaboratively on the same project. So if we consider this axis as time, I could start at this point in time, work on the project, and the other person just needs to wait until I'm done with my part. And after I'm done, I send the files to the other person, and they are going to work on this, and I will wait. And after they are done, I start working on it when I receive the files, and so on. So this is one way of doing this. So what Git does is facilitating this process with the help of other tools like GitHub. So let's see how Git and GitHub work. Now let's see how Git works. Assume that we are working on an interesting Python project on our computer, and we have saved all of these files for the project in our desktop. So we have created a folder called C1498 in our desktop, and we put all of these files in this folder. Right now, Git doesn't know where to watch. So the first thing to do is to telling Git that, okay, please watch this folder. So when we do that, this folder is now called a working directory. However, Git yet to know which files should be tracked. Right now, all these files are untracked. So the next step is telling Git which file to track. Let's say we want this file to be tracked. So we need to bring this file into an area which is called staging area. Right now, Git knows that it should watch this file, and it has a snapshot of the changes that have been made on this file so far. But we haven't saved this snapshot. So the next step is bringing this snapshot into something we call commit history or repository. As you can see, something has been added to this snapshot. This contains a message telling you what has been changed, which could be really helpful to track changes. So all of these things are stored in a hidden folder next to your files. So all this history is stored under a hidden folder called .git. So now let's see how GitHub comes to play. Let's say I have a computer and I'm working on a project which is Git enabled. So I have the history of changes. I have committed a lot of useful snapshots of my files, etc. And I have a collaborator that works from their own place, and we want to work on this project together. Instead of sending the files directly to the collaborator, we're going to put everything or push everything into cloud, which is our GitHub. And then they can clone this repository, which is the whole Git process, into their local machine. Then when either of us make some changes on the project and on our local machine, and if we track the changes using Git on our local machine again, we could put this back on the cloud or push it to the GitHub. And by so doing, we always have an updated version of the code. And if some conflicts happen, if I have a question about the changes that the other person has made, we can collaboratively solve that or talk about it. Now we have a history of changes from different collaborators. It's also possible that other users collaborate on the same project. So we could keep this project private or make it public so that everybody can contribute to our project. GitHub is a really powerful tool and is being used in many large projects, open source or private. Now that we know how Git works in general, let's see how we could start working with it. Okay, the first step is to install Git on your machine. So for that, you can just Google Git, or you can go to gitscm.com. And if you go there, you're going to see that, again, based on your operating system, OS, it suggests you a version of Git. So because I'm using Windows, that's why I'm getting this. So you can just click on it, and you can either install standalone installer or portable, but it's better to go with the standalone one. So you can easily download Git on your machine, and we're going to get to this window where you could just specify where Git should go and select Git bash here. Please select that. I'm going to also check this. So pressing next is the only thing that we need to do. So here it asks for the editor. Vim is selected as the default editor. Let's stick with that. We could just go ahead and press next. Okay, it starts installing Git on your machine. Once it's done, I'd like to show you Git bash. So this is a command line interface where you could do many things. But what I want you to do is to just type in git and press enter. You should get something like this and not an error. We'll get to this command line environment later in this video. Okay, now that we have Git installed on our machine, let's go and check out GitHub. So if you go to github.com, you're going to get to this web page, which is really beautifully designed. So if you have already a GitHub account, you could just skip this part, but otherwise, let's create one really quickly. For that, you need to just click on sign up. And you need to just enter your email address. Then you can just click continue. You need to choose a password. And it's wise to pick up a username that is cool enough. So I'll just stick with Navid K. And you could say yes or no to this question. So you need to just solve this puzzle. Now you're all set. Now you could just go to your email and copy the code that you have received. Here you can just select just me or whatever a number of members that you would indicate it's just for GitHub. So I would say just me and I'm a student. So if you're interested in one of these features, definitely feel free to select one, but I'm just going to continue. Here you can either select the free version or the student version. You could apply for the student version, but I'm going to just click on the free one and choose that for this video. And here we go. Well, there's a lot of things that you could check out if you're interested, but I'm going to just show you how to create a repository on GitHub, which is our remote hub for our project. So you could easily click on create repository. Then you just need to select a name for your repository. So I'm going to select Civ 1498. If you want, you can add a description. So I would say it's a test repo. And here you can specify if you would like to anyone on the internet to be able to see this repository or not. So let's select private for now. So you have three options here. README is a file where describe your project. Git ignore specify which files we don't want to track from a list of templates. For example, we don't want to, for example, track the files that PyCharm automatically creates. And if you want, you can add a license to your project where you can specify how other users can use the package that you're developing, etc. For now, I'm just going to create a README file, and that's all. So this is what we created. Congratulations. This is your first GitHub repository. In this repository, we have only one file, which is a text file. .md stands for Markdown. And it's just a README file, which contains your repository name and the description. Now let's see how we could have this repository on our local machine. So for that, you only need to go to this part, which is code. You could download the zip file. This is possible. But we are going to use this URL and Git. So the only thing that you need to do is to copy this and open PyCharm. So let's do that. When PyCharm opens up, you can see that we have a bottom here on the upper right, which is called get from VCS. If I click on it and paste the URL that I just copied and press clone, we can see that we have our README file on our local machine. So let's review what just happened by mapping what we already know onto what we just did. Okay, so we have two environments, a local machine, which is this computer, and cloud, which is GitHub. So we created a repository here, and we cloned this repo. Okay, so by that, it creates these three state placeholders. So we had a working directory, we had a staging area, and also repo. So right now I have a file which is README under this folder or directory, which is called C1498. So this is the working directory, and it contains just readme.md that I show with the letter R. Because I cloned this from GitHub, Git already know that this file should be tracked. So R is in repo 2. Now let's say I want to develop this project and add a Python file here. So what I can do is to just right click on the directory, go to new and create a new Python file. So I can name it just test.py. And it asks if I want to add this to Git. Okay, so let's see if it works. Here we go. We have this printed on our screen. So let's see what we did. So right now I have a new file, which is under the directory, but Git yet to know that it should track this file. So let's tell Git that you need to track this. For that, we need to add this. We already did that, but let's do it again. So what we need to do is to right click on this, go to Git and select add. So right now, what we did is the following. So we don't have this blue. So let's say it's yellow. So it's staged. And it's here as well, right? But what we did, we took a snapshot of this file, which we show with T, and we have it on our staging area. But what we didn't do is saving this snapshot. So for that, we need to bring it to our repo. So again, we can right click on test.py, go to Git, and this time press commit file. This window opens up. You can just write a message which tell the users, including yourself, because after a while you won't remember what you did. So it's better to be descriptive, but really short. So let's say this commit will add. So I drop will and just say add. I can say just hello from GitHub. And then I can just press commit. Now let's get back to our project and our analogy. So what we did, we removed T from staging area. And let me just raise this one as well. And we bring it to our local repo. So right now, our T is red. So we have this T red. Okay. So this is great. Okay, we have both tests and README in our repo, and the snapshot has been saved. If you remember, we had just one file on our GitHub, which was R. But let's say I want to add this T to our GitHub repo. For that, I need to push my new commits. Okay. There are many ways for doing this, but I usually use this bottoms here. So this one is push. So if I just press this, it says that, okay, this is test.py and this commit is what I am missing in GitHub. Do you want to push it? Yes, please push it. So now let's get back to our GitHub. So as you can see, nothing has changed. I have my README file here and nothing else. But if I just refresh the page, I can see that test.py is added. And if I click on it, I can see that, okay, this is the file. And this is the message that I just entered. And the time and every other metadata that might be useful. So this is how you can use Git and GitHub inside PyCharm. Now to complete this video, I would like to show you briefly how to use command line interface and Git. So we already saw Git bash, and depending on your OS, you could have different terminals or command line interface. So for now, we're just going to use Git bash. So let's redo what we did with PyCharm. I restored the repository on GitHub. And now we just need to copy the URL. Then you just need to open a folder. For example, I selected my desktop. You need to just right click, select Git bash here. And then you need to type in git space clone space, and you need to just paste whatever that you have copied. For that, you need to just right click and select paste and hit enter. As you noticed, a folder has been created here, but you're going to get this window which says connect to GitHub. Now we need to just sign in with our browser. So if we give the authorization, and if we get back, we can see that the process has been done successfully. And if we look at our desktop, we can see that here we go. This is C1498, and we have a README file here. Now let's see how we could use Git bash or any other kind of command line interfaces, such as terminal on Linux and Mac OS or prompt on Windows. Basically, everything that you could do with GUI or GUIs, like what we saw with PyCharm, you definitely can do it with terminal as well. But it gives you sometimes more flexibility, and it's a strong tool that you should be familiar with. So let's just have a really quick tour and see how we could do the same thing that we did using PyCharm. So any command that relates to Git starts with Git. So I can just say Git and enter. And you can see we have lots of commands that we can use. We already used clone. So if I want to clear this, in order to make it easier for you to see, I can just say clear. This is a command that is really useful. So I would like to start with a command which shows you the status of your Git repository. If I say git space status, it says that my branch is up to date with origin or main, and there is no commit on the working tree, which is good. So let me just create a new file and name it test.py. Make sure that you can see the file extension. So as you can see that this py doesn't count as a format. So I redo this. And if I can just open it up and copy and paste what we already had and save this and get back to our folder, we could first of all see what we have under this folder. So the command for that is ls. If I just type in ls and enter, I can see that I have two files, readme.md and test.py. So let's see the status of Git again. So here we can see that we have an untracked file. So I can just git add and specify the name, enter, and now let's see what is the status. Now it says that the file has been moved to the stage area. So what I can do right now is the following. I can just say git commit test py. Now I can do two things. I could say -m and enter my message, add hello from GitHub. But I'm not going to do that, so that show you something. So if we don't add this and press enter, we're going to see something like that, which is a little bit scary, but it's Vim, what we already specified when we were installing Git. So you need to press any key like space or S so that you could type in. So I can now type, for example, and then when you're done, you need to press escape, column, WQ. I just wanted to show you how to use Vim for entering your message and then exiting from that. So there are lots of joke for those who get into this environment and they cannot get out of it. So we can just do escape, column, WQ, and press enter. And here we go. Now let's do git status again. And right now we can see that, okay, my branch, which is my local machine, is ahead of the remote. And it gives me a hint. It says you can use git push to publish your local commits. I can do that. So I already did that with PyCharm, and let's do it with git bash. So I do git push, enter. And now we have pushed our commits into GitHub. And if we go back to our GitHub, we can see that now we have two files and they are exactly what we pushed into GitHub.